So, welcome, folks, to the November Temporal Virtual Community Meetup. My name is Lauren. I'm on the developer relations team, and today I am joining from Ireland, taking a break from my vacation to be with you. Happy to be here, and we have a couple of talks today. I guess the first talk is from Kostas, and the other one will be an interview with Paul. And I'll start out with just some of things. Let's see, we have our blog. You can see some recent things that have come out. We have Temporal 102 course, sort of like our second course after Temporal 101 in Java and in TypeScript. And we also have a new partner program where if you need help developing your applications with Temporal, we have a list of partners, the consultancies that can help you do that, either build for you or review your Temporal application or help teach your developers. We also have Temporal schedules went GA, so that means it's been in Temporal server for I think maybe over a year now. But the GA is committing to backwards compatible changes to the server API. I'm not sure if all of the SDKs, I think they're probably all stable by now. So first they're mark exponential, what's the word? Experimental, which means that the APIs might change. But then once we go GA with them, then we don't make backwards incompatible changes to the SDK API. So this post on the right by Irina talks about it going GA and more information about the feature. And then we have a recap of the webinar from Nuon about their use case and how they use Temporal for long-lived workflows. And then we have a new series, Community Threads, where where our writer Eric goes through some questions and answers that we have on our forum, community.temporal.io. Oftentimes we have folks with really interesting questions, and we write long answers that have like really useful information that haven't all gotten yet to our docs or best practice guides, which we would like to, but get more out, but have had limited bandwidth. So for now, we've got some community threads posts coming out with some of those best practices or frequently asked questions. So that's the, let's see, blog, recent announcements. We also have the community page. You go to events and scroll down. We have today's meetup, a webinar coming up more on schedules, and then some meetups in Dallas, Melbourne, Mumbai, San Francisco. So that is what we have coming up. And now I will introduce Kostas, who is a principal engineer in Greece, and he shared on the community Slack, that's t.mp/Slack, if you haven't joined yet, about how his deck that he wrote for and presented to his company for pitching Temporal, and I thought it'd be interesting to bring him in and have sort of see what it's like for someone new coming to the product and trying to pitch it, and like what you Kostas see and what the selling points are, and then also like once you gave the talk, sort of reporting in like what the reception was and the questions and comments people had. So I will give it over to you, Kostas, and you can share your screen.
Yeah, absolutely. Let me share the screen. Let me find it. Okay, hopefully you can see it now.
Yeah.
Yeah, so hello everyone. My name is Kostas. I'm a principal DevOps engineer. I'm currently heading a delivery engineering team where we're looking at ways to improve the delivery of value for customers and the business. Temporal has been a great enabler for me personally, and I'm looking to share how it can help others. So let me go through the presentation I gave to my colleagues, and then we can talk a bit about some questions or feedback received. So this will be an introduction. The audience had never heard of it. Some of the people knew about some job systems or workflow systems, but most didn't hadn't encountered something similar before. So what is Temporal? The easiest way to imagine it is perhaps as a workflow engine. So you can model long-running workflows, could take days, years, could never end. But you can also do reasonably low latency applications, such as point-of-sale payments. So workflows are written as code, and you also have activities. Activities are other things you interact out in the world that can fail. So you might be calling an API, you might be down, so you might need to retry, whereas your workflow has to be deterministic. So different activities of a workflow can be implemented in different languages by different teams, and the workflow definition itself could be written in a separate language of the activities. There are official SDKs in various languages, which perhaps we might be using almost all of those. So we have Java, PHP, TypeScript, Python, Go, and .NET. That's, I think, currently in beta. So Temporal can model dynamic flows, perhaps even cyclical ones, because everything is code. You can model everything you can do in code, essentially. But it's more than a workflow engine. So here we like to talk about durable execution. So activities by default will come with infinite retries and exponential backoff that will keep trying until things work, hopefully. There is built-in reliability. We have durable workflows, so if something goes wrong, you can recover and continue from where you left off. You can survive failures of both workflow and activity workers. You have also other primitives and things there, like durable timers, etc. Now, we're talking about workflow, so essentially we're talking about orchestration. So a benefit you get from that is that compared to choreography, the logic for a business process is in a single place. So you can understand where we are in the process. You have everything together, including all your compensating actions. So not a benefit of Temporal per se, but the benefit of doing orchestration. Another interesting thing in Temporal is that you can store data in your workflow event log, something we will see later, which could help you in some cases to not need additional database. And you can really do a lot of you can test for your workflows because they're essentially code, and also you can use an event log from like past execution from production, so you can see that the changes you're doing will not break existing workflows. So who's using it and for what purposes? There's recently been the Replay conference, which is on YouTube. It has a lot of use cases. Especially interesting was Afterpay, which I'll go a bit afterwards. We see young brands. I think they've come in a previous conference as well. With KFC, Pizza Hut, Taco Bell, they use it for orders, etc. Netflix use it to model their Flink clusters and manage the interactions with them, deploying, the whole life cycle. Other companies like Grab use it for customer support automation. And as of August, I think it was in one of the Temporal talks, we could see more than 600 customers of the cloud offering. There's also a lot of use cases on the website. We can see the companies familiar in the DevOps space, such as HashiCorp and Datadog, and how they use it. So I'll drill in a bit into the Afterpay talk. They've been running Temporal, I think, for 3 years of production, where they process millions of payments every day. The interesting bit here was that in this talk, we talk about low latency applications like point of sale in store, and also not so low latency applications like automatic payments. It is interesting to see the challenges and how you can achieve both kind of ends of the spectrum. Though if they don't talk about super long workflows that might take months, it's a very interesting application. So I want to show a bit how it all looks, talk a bit about retries, and understand how can help us build reliable code. So this is an example taken from the homepage of Temporal. So what we see here is the default values of retries. So by default, let's say you want to do some API call to a third party, perhaps sometimes it's down, so you implement this as an activity. Activities by default will have will be retried after 1 second, then with exponential backoff of 2, so 2, 4, 8, 16, 32, with maximum interval of 100 and forever. So these are the defaults, and you can change any of these to to shoot your use case. And you also have the option to say some errors are not retriable, so stop trying because we'll never succeed, such as the it's an invalid account or not enough funds. So here we see how a workflow is depicted in the Go SDK. So we see it as code. And here we see a money transfer workflow where we withdraw money from one account, deposit to another account. If something goes wrong, we refund. So interestingly, for example, when we go into deposit, this should succeed unless there's an invalid account, right? Because this is the only non-retriable error. So if something goes wrong, then we go into compensating actions. So again, you're writing from the viewpoint of the developer, it's just code. And if something goes wrong, you get an error, and you say, it's time to schedule a refund. So I'd like to help Greg Haskins, who has made an amazing video about closure and temporal, and he agreed to let me share some of his diagrams. So, and you should check out his talk here, have the title. So what does this look like? You have the temporal server who's interested in orchestrating and making sure the right work is done by the right workers. You have your client process who is requesting some workflow to be scheduled. And here you have your own processes, which you develop and you run. And they have the workflow functions and the activity functions. So what happens is you would run these in your own hardware, in your own network. They would do long polling to the temporal server asking for work, and the temporal server would arrange for them to get work. So temporal is agnostic to what you're doing, but make sure that everything happens. So an interesting part of temporal is the event log. So what we see here is we see a workflow where we request workflow A to be executed, and workflow A does activity B and C. So this is depicted here in the event log. We see what will end up being recorded there. So this is the client, perhaps your own application that you will build, or a CLI you might run, but somehow you invoke a workflow to the temporal server. The temporal server schedules it to a worker process where it will start running, and it will decide to evoke activity B. We talk to the server will assign it to the right worker again. Activity B runs, completes, gives a result. The result comes back to our workflow. And then our workflow decides to evoke C. And the same happens. The workflow returns a result to the server, and the server to the caller if the caller wanted to get a result, and then just raise it asynchronously. So all of these are recorded here in the event log, and this that's for certain interesting applications. One is, as we said, testability. You could replay an event log and make sure that your code still handles it. So these events could be replayed as part of a test case. But also, they help recover from failures. So let's say as our workflow scheduled activity B, requested activity B, it returned, but then our worker crashed, then what will happen is, let's say we have a second worker available, or we fix the original worker, and we stood it up again. Then the work will go to the new worker and will continue from where it left off. So essentially, what will happen is next time you have your event history with you, the event log, and as the SDK executes, here it will say execute activity, but actually it is scheduling an activity. Next time you come in here, it will see that I have already scheduled the activity, so I don't need to do anything. It will continue. Then you say, I want to get the result, but I already have the result in the event log, so they need to wait. So this is another part which helps us with the reliability of our programs. And a last interesting bit is that we see that the results are recorded in the event log, which can help in certain simple applications for us to perhaps not even need a database if we fit within the storage limits of the event log. So here I did a live demo and I got questions. We won't have time now for a live demo, but I can tell you a bit about the feedback I got, and perhaps you may have some questions as well. Shall I go into the feedback? What do you think, Lauren?
Yeah, sounds good.
Okay, perfect. So the feedback received, let me perhaps stop the screen sharing. So a lot of people were trying to understand this new paradigm and how things fit together. For a lot of them, it was something totally new. And it takes time to understand what this is, why is it useful, why do I need something more? Like this sounds like this is my GitHub action, my GitLab job. What is this exactly? So a lot of people were trying to understand what it is, how it could be useful. Some teams were excited. They saw it as a distributed development framework. So they thought this way they can build a distributed application, and to some extent, the workflows could replace some applications, applications that are orchestrating this business process. So that was interesting, another way to look at things. Some teams also saw the potential to decompose the existing legacy system. So one way you could see it is you might have a monolith, and perhaps you start pulling these things out into your workflows. But another thing is that it could help them pivot to a newer technology. So perhaps you have this big old legacy system, and you might start implementing very small parts in a different language. Perhaps you have some legacy code where you cannot hire people anymore, and you say, okay, perhaps it's a way to start modernizing. There were questions about if we would be self-hosting it, and why not? Because I was of the opinion that we should use the cloud offering. So my thoughts were, so as a platform team, I'm thinking, how can I lower the entry barrier for people? And the cloud offering seems a perfect opportunity to try to get it in and adopt it. And if we have so much volume that it makes sense to self-host, then it's also an option. And some teams were using Quartz or other systems they had built in-house. They were interested to understand how it compares. I think there was a talk this year about a company switching from Quartz. And yeah, this was the major kind of areas of feedback I received.
Cool, thanks. I think one question I had was like, when we explain temporal as like this is how you do workflows, sometimes the question we get is, well, I'm not familiar with workflows. I don't think I have any workflows. I just write code. How does this apply to me? Is that something that you got?
I think I didn't get it because uh, I held 2 or 3 demos to different groups because not everyone at the same time. So some people either didn't get it at all, so they were trying to understand what are we talking about. So they were too preoccupied to comprehending it, and some other people might make a concrete case that this can help you like orchestrate your payment process and all the compensating actions, and we might have diagrams and explain a bit how this would work. So it's easier for them to understand, okay, this is a way that it could help me, and then they could also come up with other thoughts of their own. At which time they said, okay, can we use it? Is it ready? Is it already available in our environment? At which point they said, okay, we don't have a we don't have a license yet, but yeah, we're looking at it. So yeah, it got some interesting reactions.
Yes. So I think one of the reactions you said was some people saw it as a way to build a solution for distributed applications. Is there like a certain way of doing distributed applications that they're doing now that this would be replacing?
I don't think the specific group had distributed applications. They had I think a usual kind of service-oriented architecture. But explaining it, it did seem like, okay, so it will manage running all this code, wherever it might be. So, okay, but I do this whole process by writing the SDK code, so write normal code. So I could see how this could seem like this is a distributed application framework where you just write the blocks and just run somewhere.
Okay. For the folks that are in your organization that are already in a service oriented architecture, do you know how they coordinate between services when they have tasks that require talking to multiple?
Yeah, I was looking for a long time to find uh, a nice screenshot in one of the presentations. So what I use is essentially a state machine. So you have a lot of states. You will go and you call something, and you say, "Oh, I'm in the state of waiting to get a response from them," and then they go to the next step, and then to the next step. And yeah, I was trying to find a good image to depict that, but I didn't get it in time. But yeah, usually I think what will end up happening, and I didn't realize it until I saw that picture, you will have a state machine because you will keep track of, okay, now I am in pending, now I am in whatever status. So you end up just having all these cases and I'm trying to reconstruct where you were. Whereas in temporal, you just write code. Where you are in the flow is essentially your event log, because you will skip everything until where you left off. So you don't have to explicitly track where you are unless you need it for some reason, for some other reason. So I found that as a great benefit of temporal.
Yeah. Okay. So it sounds like you're sort of in manually implementing state machines um, land, which sort of feels like to me like manual orchestration. Like you're not using a um, you're not using choreography or event-driven architecture like writing messages to buses. You do have something that's like calling different services depending on what the state is of the process. But you're also not using like an orchestration solution to do it for you. You are doing the coding itself. Cool. Yeah, I think
Yeah,
that's a pretty
but
common place that people get to.
we do have some event-driven parts where I don't know the exact specifics. So we have some Kafka clusters.
Okay.
And there you can do a lot of the things we said. Like you can implement your retries, etc. You need to decide, okay, but if it fails, I don't want to get a whole queue stuck, and then it goes to a dead letter. And you need to deal with the dead letter. So perhaps even there, you can simplify how you think about things depending on your problem.
Certainly, yeah. Um, yeah. I guess are there other questions people have for Kostas about how he talks about temporal or more about the reactions he got?
Yeah. Suppose something I can add is I've been trying a lot to lower the entry barrier, because I was thinking, can this reach not just developer teams, but like business teams? Like, can it be more low code or no code? And I keep having that in my mind. If we get good adoption on engineering teams, what's the next step? How do we go approach business teams? Do they need an engineering team to help them automate this stuff, or can we enable them somehow? Like we write the platform, they provide the content in a way. But yeah, that's a regular subject I'm trying to figure out in an amazing Slack community you have.
Yeah, I think I've seen people work on that different times. Sometimes like for an end user to be able to like use a GUI to write a workflow, or if, for like internal business users to set things up. Well, thanks so much, Kostas, um, for sharing. I was happy to meet you, and happy that you're such an active participant in the Slack community.
Yeah, thank you for having
Uh,
me.
Welcome. Next up, we have Paul Nordstrom. Welcome, Paul.
Thank you.
For those who don't know Paul, Paul is a principal engineer at Temporal. He joined in mid 2021, so pretty early on. And before that, he worked for almost a decade at Google. Uh, Worked on a number of things, including Millwheel, a highly high throughput, fault tolerant stream processing framework. And before that, he worked at Amazon from 99 to 2007. So it was designer architect of a lot of changes to the code base, including the change from monolith to microservices. So he's worked for a long time in the field and seen and done a lot. And I'm very happy and honored to have him at Temporal and to have him here at the meetup today. So my first question for you, Paul, is I heard that you retired in 2017 and you came out of retirement in order to work at Temporal, and I'm curious what that story was and how did you make that decision and how it was so compelling.
Yeah, that's very much true. I had actually a long background with Max. I worked with him directly at Google and a little bit more tangentially, but certainly, very much really worked with him at Amazon as well. And I had at Amazon, I don't think very many people know this, I had at Amazon been working on a workflow framework of my own at the time Google took me away from Amazon. So when I saw the potential impact of Temporal, when I saw the model that Max had evolved from his workflow frame, we didn't know we each were working on it at Amazon at the same time, but in fact, we were. So I'm a very much a framework and model kind of guy, and Max's model was far superior to the one that I had. Sort of. I mean, who knows if I would have gotten further with it because it got interrupted. But Max's model was better than anything I had come up with, and I thought it was just brilliant. So that's what sort of pulled me in. And I'll be honest, I didn't really like retirement either. I enjoy solving problems, and none of the problems I was solving in retirement or in my sort of just pure personal life were satisfying my intellectual needs.
I see. I'm curious. I know you were part of the beginning of Temporal's cloud product and part of our decision to build our own database that backs the Temporal cloud version of Temporal Server, and worked on that a lot. I'm curious how we decided to make our own database.
So I'm gonna preface that answer to that with a couple of things that I think would be useful for this audience. If you look at most people's pictures of Temporal, they look like this. You saw this only 2 seconds ago. The server's a black box, or in this case, blue. And most people don't think too deeply about what's going on in the server if they're writing client code. And in a sense, they shouldn't have to. But when I'm in a developer, if I'm working on a client, I actually really like to know what's going on the server side, up to the point I can. So so I'm going to be talking about that black box here. And like I said, this is a very long-winded way, but I'm going to answer your question, I promise. Plus, I also wanted to mention that I'm very interrupt driven, and anybody who has a question along the way, actually happy to have them put up their hand using the Zoom thing and just ask it as we go. You don't have to save everything to the end. This is supposed to be a fireside chat. If we were actually sitting by the fire, you wouldn't wait until I was done. Plus, I'm not as organized as Kostas, and I didn't prepare a presentation as much as I did prepare a list of talking points. So that even more should drive us towards having a conversation here. So, the project I was brought in to work on directly, the first project I was assigned was, take our cloud server, which we were running already, and it wasn't in GA yet, and extend it in every dimension to, in the long-term approach of building a cloud service at like internet scale. So pay attention to reliability, latency, multi-tenancy, efficiency, scalability, all at the same time. And that's a tall order. We picked a project, we picked a piece of that puzzle to work on first. And because we had serious scalability issues, in fact, we had a customer that we were afraid would exceed the capacity of our server. Within a sort of the visible horizon of time, we looked first at the scalability aspect, and then we looked first at what was our our point of contention, our constrained resource. And the first thing we found out was that Cassandra, the underlying database, was the primary problem that interfered with scaling of Temporal server. So the next step, of course, was, well, how do we go about fixing that? And we considered everything. We considered, other databases. We considered ways to scale Cassandra better. But at the end of the day, we took a step back and said, well, what's really the problem here? Why is Cassandra not scaling? Why won't other databases have that same problem? Because we are using 1% of Cassandra. We are using this pseudo-relational database. It's got a relational API, at least. We were using the relational API in only a very few rare cases. We decided that the best approach, the best long-term scalable approach, was to customize that to the exact problem that Temporal Server needs to solve. Temporal Server does more or less the same thing over and over again, extremely rapidly, extremely high volume, with requirement for extreme reliability. And and Cassandra is a fine database, but it's not customized to our problem. So what we decided to do was customize Cassandra to write a custom shim, let's call it, a database that handles these rare use cases, these very fine-grained use cases that are so endemic to the problem that our server solves. So we didn't write we talk about having written a database, and we did. What we have written is a database. It's, it's ACID, it's durable, it's everything we need it to be, but it's not general purpose in the slightest. So how can you write a database, with a team of very small teams, 3 people really working on it for the first year, by doing only the piece you actually need? And that's both the why and the how of the database work we did in the team. So the team is called CDS, just so I can refer to it while we're talking here. And the architecture, we now call it Cloud 3. Because we were on Cloud 2 when we started. So that's where we ended up. We ended up with a database that has, and I'm going to show my screen again. I do have a couple of slides here to show you. That has very direct correlation with the internal logical architecture of our server. This is inside that blue box we saw a minute ago, and it shows a shard. We have a sharded architecture, and it shows a host for those So there's multiple shards, and there's hosts for the shards, and so on. And we have a write-ahead log. And then we still actually store key value data in Cassandra. So we haven't completely abandoned Cassandra. So that's, like I said, somewhat long-winded answer to the question of how did we decide to build our own database?
Thanks. So let's see. We had a customer. This is 2021. We were sort of like our cloud service was like in a private invite only like beta thing, and we saw their usage growing, and we saw in the near term, like a year or two, them surpassing the ability for the open source version of Temporal server, which is running on Cassandra, to handle their load. So we were like, okay, we need to fix the Cassandra thing. Looked at other databases, not good. And then decided to make a shim layer for some or all of the operations, so some of the operations before they hit Cassandra.
Right.
And so what improvements to the server version of cloud or our custom database have we deployed already?
So the out of the box improvement, we tried to measure, and we in fact couldn't reach our scaling limit. We measured it up to, so the old version of our server, and this is something of an estimate, but we pushed pretty hard. We felt at the very maximum, because we had it didn't scale linearly. Adding resources to our let's say Cloud 2 server does not continue to add capacity at some point, and it's somewhere in the range of about 140,000 state transitions a second. So that, of course, we can deploy multiple servers. So that doesn't mean we can't handle that as more than that as a company, but a single customer in our design world can't be across cells from a scaling perspective. So when we got to the point where we had the architecture, the picture I just showed you working, we decided to let's see where what have we accomplished here? We ran a little project called MPS, which stands for million per second. We decided that if we could, get another zero on our scaling, we would call that a win. So we spent only a couple of days, sort of tuning and finding little, finding issues, finding bottlenecks in our design, but they were all easily fixed. And we were able to accomplish that million per second goal. It was very expensive in Amazon resource costs. So we stopped at a million per second and said, okay, we had yet to run into a fundamental limit though. So we don't know where we could go with that if we really had to. I suspect considerably higher than a million. I'll leave that. I don't want to be on the hook here with any of the people here or with my boss for how much we could actually handle. But I would be comfortable taking a customer that ran at a million per second at this point with preparation and scale tests to guarantee we're fully stable at that. But the nice thing about the architecture, that's the measurable point, but I think it's just as important to look sort of underneath the covers a little bit of the server, and you start realizing that because of the design, we have a super linear system. It requires less resources the harder you hit it. In other words, if you add 20% to the traffic, it doesn't require 20% more resources, especially when you're looking at burst mode. In a burst mode situation, because we coalesce writes, we just end up doing fewer writes per workflow. And so we can handle 20% more workflow load and do only 10% more writes, of to the database because of the coalescing that's going on. So that's a critical feature of the system that makes it, the stability doesn't downgrade as dramatically as a linear system would. And
is burst mode a concept of temporal server or CDS, or the custom database?
I'm using it only in the English sense of,
okay. We've got there's a lot of things going to a single workflow execution.
to a single namespace, really, is what namespace
Oh, okay.
is our sort of unit of scaling at Temporal. We can't split a namespace across server instances. And we throttle based on namespace traffic and so on. So I think of that as the primary scaling limit for our server, is what can a single namespace do. But I mentioned earlier when I was talking about the design goals of the project that multi-tenancy was a key one. We run a shared server, and we have to make sure that one namespace can't interfere with another. So quite a bit of the effort of the design of the system, another of these things that's very hard to measure and isn't necessarily visible from the outside, but is an improvement in Cloud 3. And you were asking before about what has Cloud 3 delivered, is more isolation between namespaces, so that if one customer has a spike, it doesn't affect another customer. And obviously, an open source server doesn't, they really don't care that much about that problem. It's all their traffic, and it's presumably all important traffic. But in cloud, we have multiple customers in the same cell, and the potential for interference between them. And so that was one of the primary design goals of our architecture was to improve that. That's not a solvable problem in the sense that you can guarantee there will be no impact from one customer to another. But you can keep it, but nothing is, that's true of all of server design to begin with, right? There is no such thing as perfect reliability either. What you need is a goal, a reliability goal, and one of the aspects of reliability is cross namespace isolation, and make that something you can measure and say, okay, well, we won't allow this namespace to affect that namespace's latency by more than some small percentage, let's say. So that's how I think about this problem, and that's how I think about the answer to your question is what did building. I don't really think of it as the building the database part, though. I think of it as the whole architecture of the server that we have redesigned for Cloud 3, which extends past the database and into aspects of the problem like the one we're talking about now.
You mentioned we have multiple customers, multiple namespaces in a single cell. What's a cell?
A cell is it's not a perfectly designed or perfectly defined concept, but broadly speaking, a cell is all of the infrastructure resources to offer all of Temporal services, the smallest unit you can have of that. So if we're going to have Temporal server running in, let's say, US East, okay, we have to have a set of products to serve that. We need the host that I showed you in my little picture a minute ago. We have to have the front ends that are receiving the incoming connections. We have to have the matching service. We have to have visibility service, et cetera. So broadly speaking, if you just deployed all of that to US East, you'd have a cell, okay? Now, why did I say it wasn't a perfectly well-defined concept? Because it seems like I just presented one, right? The reason is that if we deployed a second group of servers to handle, let's say, a different set of namespaces in US East, a few things would be shared across those two cells, right? So everything in a cell isn't actually part of a cell. Visibility, for instance, is not part of an individual cell. It's shared across cells within a region. So there are regional components to the Temporal architecture, okay? And they are shared across what we call a cell. And so in a certain mathematical sense, a cell is everything we've said it is. It's the front ends, it's the history server, it's the matching server, it's some other service, internal services used by those, et cetera, et cetera. And we've declared that to be a cell, and it's one of those things what it is what it is, and you kind of have to accept that that there are things outside of a cell needed by a cell to serve our customers. But we think in terms of these cells because most of our scaling has been designed to be measured and adjusted, if you will. Like we can upscale a cell and downscale a cell independently from each other.
Okay, so the measuring the way we measure cell performance, which you talked about earlier, was state transitions per second. Is a state transition every time a temporal server writes to persistence?
No, we count it as a state transition. State transition is another one of those things that it's very hard to nail down, because there are things that traditionally, it was the original design of the state transition was just to measure the load on the system. And so it was sort of the imposed load. And what you just described was the load on the database, right? So if it's persisted, it becomes. So we count things as state transitions. If a workflow is started, right, there's at least one state transition there, right? Because it went from not existing to existing. So I think that the best way to think about a state transition is if the mutable state gets touched. So if a change in the logical mutable state of a workflow, there's a delta there, that's a state transition. And so we don't count as state transition as if you just go read a mutable state, for instance. But changing the mutable state of a workflow does not necessarily hit persistence, right? We may change it 4 times and then write the delta to persistence to Cassandra in that case. Of course, there's some persisting going on anyway, because we're fully durable architecture. So even just a simple change to the mutable state is in fact does hit some sort of persistence. It hits the write-ahead log at the very least. These things are hard to, making them theoretically correct does not mean you've reached the most useful definition. So we have centered on the more useful definitions of these, which are kind of dirty, rather than sort of theoretical, like a well-defined mathematical, every time you touch persistence, it's a state transition. That's a nice mathematical definition. But if that's not what really drives the load on the system, load causes systems to fail, right? You overload them, they fail. So we want to measure the load that is driving a system towards its capacity, driving it towards failure. And so we attempt to, in a sort of very practical way, define a state transition. So I see there a question from Kostas.
Yeah, so I was wondering, when you have retries of activities, you don't get a new event, but there are many that retries have happened. So is that a state transition or is it not?
Yeah, that is absolutely a state transition. As the server has to do work there, and like I said, we're really trying to measure the load on the system in a useful way. So we count things like that 100%.
Perfect.
So earlier you talked about, so state transitions is a metric in the open source version of the Temporal cluster, and it's not something it's not something we expose on cloud. And we thought we could get up to 140,000 state transitions per second per cluster or per cell, based on Cassandra, like by just putting on more partitions and more nodes of Cassandra and more nodes of all the other services in the cluster. And we measured in the new custom database version of the cloud server, measured to a million state transitions per second, and we believe we could go farther beyond if we tuned more and if we threw more money into more resources during the test.
Right.
Cool. So in the diagram you had, you talked a little about the shim that is on top of Cassandra, and in the diagram you had walls. You had a couple of walls, and a wall is short for write-ahead log, and the benefits we get from that are it takes less, so better latency so it takes less time to write to the wall than it does to Cassandra. Is that one?
Yeah, that is one of the key benefits. I estimate about 10% actually the cost of a wall write compared to an actual database write. I have not done terribly deep analysis of that because there's so many differing sort of variable factors in that. The write to a write-ahead log is also very consistent. The variance on a write to the wall is significantly less than the variance of a write to Cassandra, and so making the system predictable is a useful feature in it. So whether it's 10% or 15% or 5% isn't really the issue. It's significantly lower latency. It's significantly less costly, right? We can afford to do that many more times per second in a monetary sense, which is valuable too. It's also sort of more, there's a single point of contention in Cassandra, the index of Cassandra. It's a global index, right? So in at least the logical sense, the Cassandra database is being hit by all of the machines in a cell, and that's not true for the wall. In fact, the wall exists with more or less infinite scalability at the shard level instead of at the cell level. So we can add capacity to the wall more easily. We can scale it more linearly, and the writes are lower latency and lower variance all at the same time.
And less likely of locking, so higher throughput of updates?
I wouldn't call it locking. I mean, it probably is, in a sense, it is locking, but it's also CPU contention too. So I'm just going to call it contention.
Okay. And then we're writing much less frequently to Cassandra, so we're alleviating the load on Cassandra,
right?
Which raises our max throughput of things coming to the server that we're handling,
right?
And then do you? So I'm remembering that walls are significantly better on spinning disks because you're writing sequentially. Does it also help or relevant from that perspective in a solid state disk world?
We have explored differing configurations of our wall, and including going from Rust to spinning Rust to solid state and so on. I believe right now we're still on a solid state wall. The boxes that are behind it. Solid state actually has pretty significantly less variance too, and like I said, we care about the variance. It's not just the throughput. It's easy to imagine that. So first of all, let me say, I should have started with, I think you're correct. Okay, that at the very least, this approach, this design, gives us more options with respect to using, let's say, spinning disks for our wall. We could easily, for instance, configure a cell where we weren't latency sensitive. Let's say a cell was going to be targeted directly at customers who had big batch loads. They care about throughput. They don't care about latency. They just want, it's their monthly billing. It's got to be done within 8 hours. But it's all about throughput. Any individual workflow in that, one of them takes 5 seconds. Who cares, right? As long as all trillion of them happen within 8 hours. And so I can easily imagine as our business diversifies and we have sort of more customers, and then that gives us the ability to group customers into like sort of shared performance requirement cells. We could run a cell with spinning disk walls that would have plenty of throughput, lower cost, and they wouldn't, the latencies would be higher, but we didn't care. So right now though, we have we just finished the transition from Cloud 2 to Cloud 3 literally last week, and so we don't have we haven't had the time yet to do all the exploratory deployment scenarios that you just asked about yet.
Christian asked in chat, for this new DB architecture, is this proprietary to Temporal's cloud offering, or would it make its way into the open source version? It's
a great question. In fact, it got asked at the, I talked about this at Replay as well. It's really not so much the proprietary nature of it. We very firmly support our open source version, but teaching somebody else how to run the CDS server, the proprietary database, is effectively impossible. There's a whole bunch of components that it depends on that aren't part of open source. And for instance, we wrote the wall ourselves, and the wall code is, we certainly don't have the resources to create let's say, a documented deployment scheme for that. a documented support regime. We can't release something to open source that people will only fail to run. Right? Let's just stop right there and say, if we were to try to do that without investing many man years of our resources that we kind of don't have, compared to other things that we can do that will definitively enhance our customers. So that's basically the answer to that.
Okay, so I'm curious, what latency improvements do you expect to come in the next year?
I have so here I have to do a little caveating here, because first of all, I always get in trouble because I actually don't mind talking about the future, but then I get
These are forward-looking statements.
Yes.
Do not hold Paul or Temporal Cloud to words Paul says.
Please don't get me in trouble with being, but a fireside chat is at least the place where you should try to be open kimono about these things. So the thing about latency, and in fact, the other measures of improved performance that we've been discussing, is that they're nuanced. So it's quite possible, for instance, to address the latency of start workflow in a way that applies only to that use case, and won't affect an update or won't affect the processing of a task. Task dispatch is one of the places where, if you take a workflow from start to end, right, from started to completed, and then migrated off to tiered storage, you find that different customer use cases exercise different parts of that system in widely different ways. Some people, the start workflow phase of a workflow is a tiny percentage of they run for weeks and they have thousands of events, and start workflow doesn't impact them at all, doesn't improve the customer's life. Other people have very short-lived workflows, and start workflow might be 30% of the latency, or it might be the only part of the latency they care about. As soon as they've started the workflow, it's going to run, okay? But they need the start workflow to happen like that. So I'm talking about this one because it's one of the ones we're directly working on. There's a fair number of use cases, quite a number of use cases where start workflow is critical. And so we have been working quite hard on an optimization to start workflow that should speed it up in a quite significant way. So I think that you're going to see progress there, and certainly. I shouldn't say never. I didn't say certainly. I didn't say that. We are working hard on that one, and I hope to see progress there in sort of the foreseeable future. Okay. Another one is our reliability. The architecture itself. I mentioned that it has this super linear thing. You can imagine that means it can stand up to a burst, and not. And bursts happen in the real world. They can happen because of intentionally or unintentionally, right? A customer could DOS us, or they could unintentionally DOS us, right? There's all sorts of things about reliability. I'd say kind of the majority of our work right now are going towards efforts that improve our reliability, but we tried very hard to make just as the original CDS design worked, improved both throughput and latency significantly, and in some dimensions reliability. We are working on other things that are primarily aimed at reliability, but also will impact latency and throughput. So actually, in a certain, I think it's not unfair to say we are going to attempt to improve in every dimension of the optimality envelope, if you will, over the next year. But which part, how much of each one is that's more really what's up in the air.
All right. Well, I guess we are out of time for today, but thank you so much, Paul, for answering all these questions, and for Kostas for sharing your presentation. Paul was worried about not having enough to talk about. We have many questions we haven't gotten to. And I could keep on going, and I hope we will have time for more talking with Paul later. But I hope y'all enjoy the rest of your day and the rest of your November and December, because we will be off for December, but back in January. So happy holidays, happy New Year. See ya.
Yeah, happy holidays.